Before we dive into the projects, I'm going to provide a big picture overview of the certification standards we'll be covering today and how they're the same and how they differ. We'll be discussing LEED, Living Building Challenge, Passivhaus US and International, Low Carbon, which is a step towards zero carbon, and WELL. So let's start with LEED, the broadest of these certification systems. It covers topics related to water, site, a project's location and how people get there, indoor environmental quality, energy, materials, and includes an integrative process. Living Building Challenge takes all the topics covered in LEED and dives into them very deeply. It also adds 2 more topics, advocacy and community and equity. Passivhaus dives deeply into energy-related topics and dips into indoor environmental or air quality as a byproduct of the standard. Lower zero carbon goes deeply into both energy and materials. WELL lightly approaches location and transportation, energy and atmosphere, materials, and an integrative process. It also goes deeply into indoor environmental quality topics, which have a tremendous impact on the building occupants. And unique to WELL, of all these certifications, is the explicit incorporation of strategies that positively influence the health and well-being of building occupants. So up next will be Sangeeta, who will be focusing on Passivhaus.
Thank you, Christy. My name is Sangeeta. I am a project architect and CPHC at WRT. The project I'm about to share is a multi-phase, multifamily affordable housing project in Hartford, Connecticut. This is a former 40-acre public housing site. And when all 8 phases are completed, we'll have more than 400 new residential units. This is a mixed income housing and a mixed community. Phases 1 through 4 have been awarded the LIHTC low income housing tax credit award. Phases 1 and 2, that is 6 buildings of phase 1 and 6 buildings of phase 2 are constructed and fully occupied. Phase 1 has been certified to meet PHI standards. Phase 2 will be certified to meet PHIUS 2015. Phase 3 is currently in construction, which is 6 buildings of phase 3 will be certified to meet PHI standards. Phase 3 also has a community building in the center of the site. Phase 4 has been awarded tax credits and will also be certified to meet PHI standards. And we are currently in the process of designing phase 5 to be submitted for tax credit application end of this year. And we are exploring PhiusCon 2021 or PHI. So we are yet to decide the compliance path. And this is the unit distribution for phases 1 through 5. So this is primarily a low-income housing tax credit application process, that is the LIHTC. And the Passivhaus is driven by the QAP, which is the Qualified Allocation Plan. And as you can see here, this is the most current iteration of the QAP. It is a tiered and a point system. And a Passivhaus is listed part of the energy conservation criteria. And we are excited to see as this current iteration is listing balanced ventilation as a prerequisite as part of energy conservation. And we are exploring for phase 5, we are exploring Passivhaus. And as mentioned, we are yet to decide whether we will be going the PHIUS route or PHI. And including energy conservation. There are other categories listed here, and phase 5 will also be seeking National Green Building Standard. We will be going for Emerald standards. This is the Passivhaus building envelope components. We have a subslab rigid insulation to comply with an R20 or an R30 for most buildings. So most buildings it's R20. There are a few buildings we had to bump this up to R30 to meet Passivhaus compliance. The wall component, the wall assembly is a zip R12 exterior sheathing with a R21 bat system to make up for a R33 total assembly. And the attic is a R100 attic roof assembly. And as you can see here, the Passivhaus air barrier, the continuous air barrier excludes the attic, and it also excludes the sprinkler rooms in each building. Most buildings are 3 stories high, and we do have a few buildings in phase 1, which is 2 stories. And this is the predicted EUI for phases 1 through 4. This is the worst case for each phase. These are some of the Passivhaus envelope features. As mentioned, we have zip R12 sheathing. We have, for phases 1 and 2, we had a masonite exterior door for the units. And this is a non-Passivhaus rated door. For phase 3, we are going with a Provia door, and this was definitely a better air seal. All windows phases 1 through 4 are Alpen triple glazed windows. This is a larger window which we have in the management suite, which is in building 2 of phase 1. The ceiling, to complete the continuous Passivhaus air barrier, we went with the zip sheathing ceiling system. You'll see a little more, I'll discuss in a little more detail in a minute. As mentioned, the sprinkler rooms have been excluded from the Passivhaus thermal and air barrier. And the subslab vapor barrier is a robust 50 mil stego vapor barrier here. These are some of the mechanical components in phases 1 through 4. For the 1-bedroom units, we have a wall-mounted mini heat pump system. For the 2 and 3-bedroom units, we have a ceiling-mounted ducted heat pump system, 1 per floor. One on, that is for the stacked units, we have 1 on the 2nd floor and 1 on the 3rd floor. All units have their individual tankless gas-fired hot water heaters. All units also have their individual Zender ComfoAir 350 ERVs for the energy recovery ventilation. Each phase has a small PV component to comply for most of the site lighting requirement. And each unit also has their own washer and dryer, and the dryer, all dryers are heat pump ventless electric dryers. Back to the hot water heaters for a minute here. Phases 1 through 4, as mentioned, all have a gas tankless hot water heater. Post tax credit award for phase 4, the design team and the client was very interested to go with an all electric building, and we did test our Passivhaus models for 40-gallon tank electric hot water heaters, and unfortunately the PHI energy models did not comply. The primary energy demand was beyond the Passivhaus threshold. These were pre-certified. Phase 4 was pre-certified to meet PHI compliance. So we tested these only in PHI models. So here's an example where the certification standard kind of does not live up to where we would prefer it to be. And the design team was quite disappointed that we couldn't go with a tanked electric and go for an all electric building. However, in phase 5, we are going with with all electric buildings. And we are currently testing heat pump hot water heaters for phase 5 and hopefully looking to comply with either PhiusCon 2021 or PHI international standards, Passivhaus international standards. These are some of the construction details for phase 1 and 2. The design detail is what you're seeing on the left here. We kind of had the stego vapor barrier right up the exterior zip sheathing to meet the zip R12 and to make a continuous air barrier. However, the GC found this detail to be hard to manage on site, primarily because the stego, they couldn't maintain the stego wrap vapor barrier. So during construction, we kind of edited the detail, and this is where we ended up. So we did a combination of self-adhesive membrane and fluid applied air barriers for a continuous air barrier at the foundation stem wall. This being a multi-phase project, as part of lessons learned, we are able to incorporate and make for better air seal and easier construction details. And this was a detail we worked with the GC, again, on their request. They really wanted to align the exterior zip R12 sheathing with the concrete foundation stem wall for an easier, smooth transition. So we kind of cut back the stego, a 15 mil vapor barrier, came back and kind of had a combination again of fluid and member vapor barrier to make it a continuous air barrier. Basically, we were able to discontinue the stego, kind of terminated at under the sill plate and continue the continuous air barrier with fluid applied and membrane air barriers. What you would see here is, yes, this made for a larger thermal bridge as when compared to the construction detail of phases 1 and 2. So we had to take that thermal bridge penalty in our term, we had to model that in term and take the penalty in our energy models. This is the continuous vapor barrier, continuous air barrier detail at the ceiling, where we incorporated a zip ceiling at the interior detail for this is phase 1 and 2 construction detail. Again, as part of lessons learned in phase 3, we kind of structurally broke the zip R12 sheathing at this intersection here for a better air seal. And as a result, we had to include these structural bracing straps for structural integrity. But this definitely made for a better, like a tighter air seal, because in phases 1 and 2, as part of the final air infiltration testing, we found a lot of air leakage at the truss heel location here. So this definitely helped with that, as you'll see in the next slide, where we were getting whole building air testing as almost to like half the required threshold. So Innova Services Corporation is a Passivhaus verifier, and as these are low-rise buildings, during the construction process, we had to accommodate for this 12 by 12 temporary openings to complete the Passivhaus final blower door testing. And after the completion of the final whole building testing, the GC had to come back and air seal and fire seal these temporary openings. And then we did the compartmentalization testing. And these were the areas where we were finding some air infiltration issues. And we had to get, especially at the truss heel and around the windows, so a lot of initial testing had to be done prior final blower door testing. These are some of the big picture differences between Passivhaus international standards and Passivhaus US standards. The space conditioning targets, it's the big difference here. The space conditioning targets for PHI, the international standard, is mostly a 1 threshold for all climate zones, whereas the PHIUS standard is more climate specific. It's very climate specific. The energy threshold here for PHI is a primary energy criteria, and it's a source energy criteria per person for PHIUS. The air tightness for PHI is air changes per hour at 50 pascals requirement, whereas for PHIUS, it's a envelope criteria. And the Passivhaus area calculation is also a little different. It's treated flow area and interior condition flow area for PHIUS. The modeling software is also different. And a big difference to note here is the space heating and cooling criteria thresholds for the PHIUS, for the PHI standards. We are required to comply with heating demand or heating load and cooling demand or cooling load. Whereas in the PHIUS standards, we need to comply with all 4 criteria, which is the heating demand and heating load, cooling demand and cooling load. These are some of the construction photos, completed photos of phases 1 and 2, and a few photos, construction photos of phase 3, and that's the community building in the heart of the site. As we are excited that we will have a total of 260 residential units, all certified to meet Passivhaus standards. We are very excited for that, but we are hoping that down the road for subsequent phases, we will be able to incorporate embodied carbon thresholds as well. As you know, Passivhaus is great at having a higher energy efficiency and a lower operational carbon target, but we are hoping to also kind of look into embodied carbon for future phases. Thank you very much, and over to Ilka. Thank you.
Hi, I'm Ilka Cassidy, and I am an architect and Passivhaus consultant and co-founder of Holzraum System and C2 Architecture. I grew up and got my degree in Germany, but I have been practicing and living here in Philadelphia for almost 20 years. In my presentation, I will focus on PHIUS certification and where I feel we need to step back and look at our goals and priorities through a broader lens. So PHIUS certification works well for single family homes, and that has actually been most of my certification work. I see the great benefit of this certification in the project reviews by highly qualified PHIUS staff, as well as on-site quality assurance by a certified rater. I believe that certifications give leverage to consultants, architects, and homeowners, in particular women. So PHIUS uses WFI Passive as the main energy modeling tool. And the performance targets are climate specific and get calculated through this online calculator to the right. WFI is a great and crucial tool, and without all these nice green check marks, we can't obtain certification. So therefore, a lot of decision making is actually based on the energy model. So, but the question is, does WFI always give the path, guide the path to the best possible outcome? I feel like sometimes I have found myself losing sight of optimal sustainability, comfort, and health goals on the quest of reaching these green check marks. So, and these are some of the decisions where WFI and possibly best outcome don't always agree. In my experience and in our climate, WFI typically rewards windows with a high solar heating coefficient, but that doesn't always lead to the best comfort for the occupants. The building is modeled as one big box, and Wolfie Passive assumes that the temperature gets equalized instantly, regardless of orientation and exposure. What looks like a perfect balance between heating and cooling for the entire building can in reality mean overheating on one floor or room, while actually needing heat on another. Also, the exhaust ventilation in kitchens becomes basically an energy penalty and could risk the passing of the blower door test, but would in fact provide better indoor air quality for the occupant. It is also still easier to pass certification for homes with a larger building surface, while overall the energy consumption goes up. Super insulation is necessary, but unfortunately, the most cost-effective materials to reach a high R value are not the most sustainable or healthy. So Passivhaus is a performance-based standard that exclusively looks at operational carbon. But the material and process that the building is constructed with determines the embodied carbon footprint, and it is a one-time opportunity to either do it well or use even more carbon-heavy materials. Historically, embodied carbon is responsible for about 28% of the building sector emissions. To reach energy efficiency, more material is being used, and as operation energy efficiency increases, the impact of embodied carbon emission in buildings becomes increasingly significant. In a study that I did with David Salmon and Steve Hessler, we actually wanted to understand the impact of embodied carbon in our projects and find out if Passivhauses help or maybe even hurt the environment, and how we can continue to improve our projects. So for this study, we chose one of our projects, a prefabricated single-family home. And we used Wolfie to calculate the operational carbon and Tally to look at the embodied carbon. We ran calculations on 5 different cases, from code building to code building with high efficient systems, Passivhaus with foam insulation, low foam, and no foam insulation. This graph is showing the operational carbon in gray and the embodied carbon in red for all 5 cases over Tally's default 60-year timeline. So the first finding showed us that just by changing the systems, we could decrease operational carbon by 54%. By upgrading the envelope to high foam Passivhaus, we can decrease the operational carbon by another 31%. However, it also increases the embodied carbon by 6%, which we can decrease by 35% by using less foam, and 45% by using no foam. So now, why do we look at embodied carbon over a 60-year period? So with the 2030 carbon goals in mind, we decided to change the time frame to 12 years. And we did this study a couple of years ago. So back then it was still 12 years to 2030. So when we compared the results of case 1 on a 60-year versus case 1 on a 12-year time scale, we see a dramatic shift in the ratio of operational to embodied carbon. When we analyze the high foam Passivhaus envelope, the ratio becomes almost exactly inverted. The 5-case comparison shows that we can reduce the percentage further, but there's still a lot of room for improvement. But the study shows that embodied carbon is absolutely something that needs to be taken seriously and has to be tackled in an aggressive way, just how we're tackling the operational carbon. So one way to tackle it on a large scale is to look towards prefabrication. So prefabrication offers the opportunity to scale up high performance and passive house construction while reducing waste and specifying sustainable building materials. But we also have to be careful with prefabrication because buildings are getting built at a higher speed. And if it's not done right, we can actually do a lot of damage. So it's really important to look at the materials that are being used. Prefabrication is a great way to specify sustainable materials, and they are not going to get swapped out easily. So prefabrication and its nature of having to use a parts-based model gives the opportunity to figure out passive house detailing virtually beforehand and streamline their application. And then the next step beyond using low embodied carbon materials is to actually repurpose and reuse building materials. And because prefabrication requires a model and organize the data set with materials that are all accounted for, it is actually a perfect setup for a circular approach. So to summarize, and going back to certification, reaching to meet Passivhaus certification shouldn't supersede the broader design goals to achieve the best possible outcome, including sustainability and occupants' health and comfort. Certification and WUFI modeling should be a tool, which is a great tool, but it shouldn't take over. Certification is instrumental to push energy efficiency on a large scale, and it offers education, paving the way to broad adaptation. So another great certification guide for us would have been probably Living Building Challenge, and that's actually what Christina is going to talk about next. But before we dive into her presentation, we are representing women architects, and we put this women panel together on a purpose. So I just wanted to share some numbers. And these are statistics that the Association of Collegiate School of Architecture put together from 2020. So this is a very broad look at female versus male percentages, and doesn't subdivide even more into racial and further gender diversity. So of the US population, 50% are female. So what do you think the percentage of women starting architecture school is? So you can see it's just below 60%. So, but then how many are starting the architecture experience program to become licensed? So that's 50%. And then how many are actually licensed AIA members? That's just over 20%. And then we look up even further, how many have earned the AIA Gold Medal? And that's only been 2 women out of 75 medals that have been given out. And there is still a 14% pay gap between women and men. So yeah, thank you for listening. And Christina is up next.
Hi, I'm Christina Astmann, and like Ilka, I'm from Germany. We met at a previous Passivhaus conference and connected on common ideas. I'd like to present on Natech Hollow, a living building challenge and Passivhaus project that I was fortunate to work on with Ashley McGraw Architect for Binghamton University. It's an environmental science research and education center on a 75-acre nature preserve. We kicked the project off on a beautiful fall day with a team of consultants, members of the community, and also professors who contributed their research, and students were present as well. The entity that was not part of the design process was the contractor, because this is a publicly bid project, so they could not be part of the project in terms of design, but will have to be caught up in terms of all those holistic and specific requirements as part of the construction process when they are brought on board. The project started with Living Building Challenge as the main idea. Living Building Challenge is a holistic, well-rounded, cutting-edge building standard, looks at a lot of different components. And while I can't share all of those requirements in detail, I wanted to just point out a few that brought some challenges and synergies with them. It includes 7 petals and 20 imperatives. You're looking at a very well-rounded host of different ideas and considerations. It starts with beauty, place, health and happiness, and equity. And it moves into like some more challenging requirements. And the most challenging, I would say, is the material requirement. Here we're looking at the red list of materials of concern that cannot be included in a project or need to be vetted in terms of like, material transparency. We were happy to work with students from the university, and then also with vetting team from Integrated Eco Strategy that helped us with some of the material research for this project. We also need to understand and offset and raw need carbon. We're looking at regional materials as part of this project, and reducing and eliminating as much waste as possible. Next petal that is challenging and definitely had some challenges that came together here on this specific project is the water petal. You're looking at completing a complete water cycle. So net zero water is a big consideration. You want to capture the rainwater on site and also have wastewater treatment on site as well. Another challenging petal is the energy petal. And Living Building Challenge calls out for 105% of the energy consumed annually needs to be produced through renewables on site. That could be photovoltaics, that could be wind power. And so as part of this requirement, you also cannot have any on-site combustion. So it really sets the path for electrification and also has a big focus on resilience. This is why we brought in Passivhaus, because with Living Building Challenge, you could theoretically build a code-compliant building as long as you have the funds and the space to have your renewables on site somewhere to like produce the 105% energy that you need to comply with the energy petal. But we thought that, we needed to bring something else to the table, and Passivhaus, in addition to being such an energy efficiency focused standard, brings also high levels of indoor air quality with it, thermal comfort, acoustical qualities, resiliency, so we can cope through power outages. So it seemed to be a perfect match for Living Building Challenge in this regard. We also have a very wooded site, so it wasn't possible to like really, tear down trees, cut them down to create some photovoltaic arrays on the ground. We really wanted to have it integrated with the building. The building is fairly small. Wanted to mention that I think of it as klein, aber fein. That's a German term that means small but special. Lots of big consideration went into a very, very small building. And in this case, we were working around an existing footprint that incorporated the outline of an existing building that was on site, and then like trying to like pair it up with like a new building structure that has perfect solar orientation. So to bring those two together, we had a small roof area that we're working with. And so with that, we needed to stay as compact and high efficient in our envelope design as possible. And also wanted to mention that photovoltaic panels have a high embodied carbon. So the less panels that you use, the less embodied carbon this will also account for. So definitely another additional consideration. We started with this project with PhiusCon 2015 as like the baseline, and then as we switched standards, like the project went on a few years, so we were able to like actually upgrade to 2018, and were able to cut out half of our exterior insulation as part of that process, and then still were able to meet all the requirements set forth. So that was really interesting to see how like the Passivhaus standard evolves over time. And in our case, it helped us be also more cost effective and while still meeting all the targets. This project is fairly small, as I mentioned. It includes a multi-purpose room in the center, then also a lab space, and then also has like mechanical rooms as part of this project that really is almost the centerpiece of the project, because it's like a teaching tool. So you want to bring in students and members from the communities to learn about high performance buildings, and how all of these different systems work together. As part of our project, we wanted to use that existing building that was on site and some of the elements, save them as much as possible. And one idea was to actually retain the existing foundation wall that was set here on site. You see the red line that, outlines the foundation wall. So that's something that we wanted to capture. And with it, the embodied carbon that is attributed to this building element. With it came some challenges, because as part of Passivhaus, you're trying to like have your continuous area barrier that goes all the way around, and with that also continuous isolation all the way around. Well, if you have an existing foundation wall, you cannot insulate underneath that. So, we had to incorporate this inherent thermal bridge that we will encounter into our considerations. Definitely is worth the effort, because, it tells a story of like, where the building came from. It's important to kind of root the building within its site. So that's how we kind of came up with this idea. I've never talked about bodily fluids as much in my life before starting this project. And in this case, with the water pedal, we also wanted to incorporate a composting toilet, which is outlined in the larger within that larger footprint of the mechanical composting area, and within it sits the composting toilet, and then outlined in the darker color. And this is really meant to be on display to teach people about, the water cycle and, like how all these different systems work together. As part of this consideration, we had to work with trying to figure out how we can make the composting toilet work in terms of like, what it means for Passivhaus. Because the composting toilet needs continuous exhaust to work. And also to create negative pressure at the fixture, the toilet fixture itself. And so we worked with some different ideas here. We thought that maybe we can run that continuous exhaust through the energy recovery ventilation system for the whole building. But there were some concerns about odor dispersing. And so we thought that maybe if we add an additional smaller dedicated heat recovery ventilation system to just the composting toilets, we could mitigate that in terms of energy penalties for our energy model for Passivhaus, but then that was also way too costly to make sense. And so in the end, we worked with the composting toilet manufacturer to dial down how much continuous exhaust we actually need to provide to make the system work, and so to fine tune and dial down the energy penalty that we have to account for in our energy model. We also did some studies in terms of embodied carbon on materials. And one example here is the insulation. We compared wood fiber insulation to mineral wool insulation, also thought about, all the different functions that those insulations need to have. And because the part of our building is kind of set within the earth. It's like kind of an earth-sheltered volume. And so it has contact to moisture. It made sense to use mineral wool. Also, it has a less favorable carbon footprint and compared to wood fiber. So, all of those ideas, there are so many different considerations you need to bring in when you make a decision. And it's not always super straightforward. And, sometimes one of the priorities will kind of set up the path for determination. Another thing that we looked at were windows. Our idea was to have a fairly, simple material palette. And with that, we wanted to include as many natural materials as possible, and wood windows made sense. We also wanted to have them aluminum clad from the outside to just prevent against the exposure to weather. And so we worked with a manufacturer in Chicago, so that's fairly close in terms of distance from the project site. For Living Building Challenge, you have to account for different distance radii within, your project in terms of living economy sourcing. And that means that, you have to, find regional materials as much as possible. In this case, this manufacturer is set in the second radius of distance that is allowed and can be accounted for Living Building Challenge. And we worked also with them on FSC certification because they weren't a certified shop, but agreed to get the certification so we can comply with the Living Building Challenge requirements. So it's interesting to share this advocacy with some of our fellow industry partners. So it's important to kind of share the importance of sustainable forestry. So that was nice to kind of educate others in that realm. Our material palette, as I said, is fairly simple, but I also wanted to share that we try to incorporate as many of solutions that could maybe have serve multiple purposes. And in this case, our wood acoustical baffle system serves multiple functions. Obviously, it has the idea to create acoustical benefits for our multi-purpose room, but it also wants to mimic the idea of being outside in the woods and how this tree canopy filters light from above, and so kind of mimic that same idea. And with that also, we have some light filtering into the glare story that could pose some potential glare issues on the teaching surface. But because we were able to carefully place the acoustical baffles in a way that would mitigate or prevent glare on the teaching surface, we were able to combine multiple functions into one design solution. We think that Living Building Challenge is a great framework for smaller, more specific goals to fit within, and Passivhaus is one of them. There are some challenges to it also, but also very well recognized synergies, and together I think it will become a very interesting project that could guide the industry forward and in terms of pushing the envelope. This project is now finished construction documents, but is waiting for construction administration. It was put on hold during the pandemic, but is waiting to break ground as soon as possible. So that's exciting. I'm unfortunately no longer part of the project, but this was my baby for so many years and will stay very special to me. I started my next chapter of my career, and my plan is to focus on Passivhaus consulting. And with that, I want to bring in all of those holistic, generative considerations that I just discussed. My goal is to inspire others to find their voice, push the boundaries in our fight against climate change in order to leave the world a better place for future generations.
Hello, I'm Kelly Moynihan, principal at HPZS, a firm here in Chicago that specializes in sustainability and historic preservation. The project I'm going to be talking with you about today is the Keller Center, which is the new home of the Harris School of Public Policy at the University of Chicago. I completed this project as project architect, formerly with Farr Associates, another great firm here in Chicago that does a lot of amazing work pioneering sustainable projects. So to give you a little bit of history about the building, we inherited this building at the start of the project. It's a mid-century neoclassicism building built by Edward Durrell Stone in 1963. And it mimics a lot of the same qualities that are found in his US Embassy in New Delhi. Sort of this monumental building placed on a plinth that, while is very formidable, is very much turns its back on the community on all four sides, because it creates this wall and this barrier to both the streets and the adjacent neighborhood. And so we really wanted to change that attitude. As a school of public policy, the idea of welcoming people of all walks of life to gather ideas to solve some of the world's biggest problems was an important goal of the project. This, however, this building was originally a hotel and conference center, so it had some large volumes that we were able to work with. But we had to inherit a lot of the strange structural qualities inside and make that work with the new program for classrooms and offices. So this is sort of a view of the northwest corner that shows our design that allowed to erode this plinth away and allow new passages and entries into the building from all sides, and creating a more subtle, gradual ascent up to the building using natural landscaping, seating areas, and new walkways. So with the facade of the building, we had to respect a lot of its historic properties, and we wanted to maintain this very unique patterning that is found throughout the building, this hexagon patterning that you're seeing. And so we had to carefully select where we removed parts of the limestone facade to create these portals, these viewpoints into the building to create more transparency and a more welcoming presence. So here the landscape plan again shows all of those moments of making this plinth, this former podium, more welcoming, more engaging with different landscape areas and places for social interaction. So the building is has a very large footprint. It's about the size of a football field, and the only glazing and access to natural daylight was on the perimeter of the building with just kind of individual windows. And one of the main goals of the project was to have daylight equity throughout the spaces, so that no matter if you were a faculty member, a staff member, a visitor, a student, studying or in class, that you had natural daylight in all of the spaces. And so luckily this building, as you'll see in the lower section, the existing section, had some multi-height spaces already in it. And for some reason, Edward Durrell Stone didn't open those to the sky and allow natural daylight in, and instead use artificial lighting to mimic outside light, which is a bit strange. But luckily we were able to, without doing a ton of structural gymnastics, open those up so that those views to blue sky and clouds were available on the east and west sky courts, as you see in the top section here, as well as the main central atrium, which really becomes the heart of the building at the Harris Family Forum, with a terrace seat step design that allows students to have both teaming and small group work as well as individual study, but allows that space to actually transform into a theater in the round 400-person event space, so that we're able to use this as a multi-purpose, multi-programmable space rather than dedicate a typical higher ed large format auditorium style classroom and dedicate those back to student amenities and faculty offices. So in talking about certifications, when we started this project, really all of them were on the table. We wanted this to be a landmark project, and we wanted to pick the right certifications that met this project's goals, needs, and desires. And where we landed was a combination of the Living Building Challenge Pedal certification and LEED Platinum. And the reason for that is that the Harris School of Public Policy really wanted to be at the forefront of higher ed design and have their building really speak about what they are about, which is changing the world and making positive change. And so in talks with them, we discussed that the Living Building Challenge being kind of the most aggressive certification system really suited them well. We would have loved to go for full Living Building Challenge. However, we had certain site restrictions, such as just not enough square footage for renewables that would have covered us to get us to net zero, as well as local building codes here in Chicago would have prevented us from doing net zero water with plumbing codes as they stand now. So we dropped it down to the pedal certification and selected to do materials as our difficult pedal as part of that certification, pairing it with equity and beauty because we felt that they most embodied kind of what the Harris School is about and the kind of message that they wanted to send not only future and current students, but any visitors and really put them on the map. But because we weren't able to do things in the energy and water department, we decided to pair it with LEED Platinum kind of as a sister certification. And they really married well because where we got to focus and do a deep dive on healthy materials in the Living Building Challenge, we wanted to make sure that the entire project team was kept honest in its requirements and goals to go for things that dealt with energy and water and waste and things like that. And so we felt that the combination of these two really worked well together to get a synergy to tick all the boxes for kind of a full circle of sustainability focus. And it worked out really great. And mostly for the Harris School, they got to use this as a springboard to really talk about themselves and being pioneers. They're the first Living Building Challenge pedal certifications, certainly anywhere on campus at the University of Chicago, but also the only one of public policy schools, and similarly for LEED Platinum. So just want to focus a little bit on the materials pedal of the Living Building Challenge, just because we can tell a lot of stories about this project because it achieved a lot of different things. But the materials pedal was really the thing that drove a lot of success in having other sustainability stories that weren't just about getting credits towards a certification. So in order to meet the Living Building Challenge material pedal, it's very difficult. You have to vet every building material that goes into the project down to 1,000 parts per million to make sure that there are no harmful chemicals to humans or animals anywhere in their composition. And so that process is very extensive. We were fortunate to have a very collaborative and expansive project team with consultants such as YRNG, now WSP, and AP Monarch to help us with the vetting of these materials. And one of the easiest way to reduce that amount of work is to keep your material palette very simple. And so because we were inheriting an existing building made of limestone and concrete, we decided to go with a very natural material palette and making sure that overall the finishes were stuff that were, basic materials such as wood, steel, glass, metals. And so that we knew that those were going to be good products going into this building. In the Department of Wood, we knew we wanted to have wood be this warm element that appeared throughout the building in different ways throughout all the spaces. And we knew we wanted to use a reclaimed or salvaged wood product, again, just furthering that sustainability story. And lucky for us, the dean of the Harris School put us in touch with local artist and adjunct faculty member, Piaster Gates, who's well known around the Chicagoland area and abroad. And we were talking with him about how to maybe collaborate on this project and what ideas he might have for generally just art, because we thought that that would be where he would be most interested. And when he saw some of our initial renderings and saw that we were wanting to use wood, he said, what kind of wood were you planning on using for that? We said, well, we thought about using different salvage materials, reclaimed materials. He said, well, I have an idea. I've been sitting on a very large pile of fallen trees from the Chicago Park District that they gave to me after they were infested by the ash borer beetle. And I've been wanting to use them for a large scale project, but haven't had a commission to do so. And he said, well, that sounds great. We'd love to, use that wood. And he said, well, there's one catch. Part of the goal was that I wanted this wood to be used and be a catalyst to build a mill in the Woodlawn community, which is where just south of where our building is, so that he could actually do on-site job training and woodworking for local residents to mill this wood to go into the project. And then the mill would continue on for years to come to continue to train people in the community. And we said, wow, that's an amazing opportunity for us to not only get in a material that we want in this building, it's also a reclaimed material, salvage material, but also we get to impact the community around us. What an amazing sustainability story. And so the wood you see in all of these spaces is really a highlight in the building, not just from an architectural sense, and certainly gives that warmth we were looking for, but also tells this story of how this building really changed this community and was able to do things that are outside the project boundaries of the building footprint, which we're really, really proud of. Another impact story I'd like to share is in the vetting process of all these materials. One thing we came across was in our roofing system. We wanted to use this Firestone assembly EPDM roofing system. And through the vetting of that and all the different layers of that assembly, we realized that there was a couple of products in there that were not compliant with the red list requirement. And so we approached them and said, is there anything you can do? We really want to use your product. And sure enough, they were willing to actually substitute some of those layers with a product that isn't even theirs, to put it into their assembly and actually warrant the entire system. And using a declare label, which is the kind of gold standard of transparency through ILFI, a GAF product into their system, into their assembly rather, and warrant the entire thing for our project. So just shows that by asking the question that most people don't ask, we were able to get a healthier, better material into this assembly and still have it warranted by the manufacturer. Furthermore, in researching fireproofing products, we were trying to decide between a few, and we came across one through GCP Applied Technologies for a spray fireproofing product for the underside of the exposed deck. And we said, we really want to use this product, but, again, you've got some bad stuff in there. What can you do? And so they said, well, let's go back to our labs or whatever and figure out what we can do. And they came back to us and said, that actually doesn't even need to be there. We don't even know why it is there, why it has been there. We're going to get rid of it. And so, again, by asking the question, they actually changed their entire formula. And now that is the way they're going to manufacture that product going forward. And so for other project teams that don't ask the question, they're going to get a healthier material because we did ask the question. Furthermore, they actually went on and were inspired to apply for 4 declare labels for 4 different products that they make, all because of the diligence of our team and the commitments to sustainability on this project. So all in all, I could tell a lot of stories about how impactful this project was, not only for the Harris School, the University of Chicago, for myself personally and my professional development, but it really is a great story about how sustainability and the certifications and the requirements of those certifications really can drive forward sustainability with a greater radius of impact. And the fact that this is a public policy school makes it very, very fitting that this would be a project that really prioritizes transparency and being at the forefront of these very important issues. This project was definitely a landmark for me personally and for FAR Associates. It won the AI Coat Top 10 Award in 2020, which as an architect who cares about sustainability is like winning an Oscar. So very, very grateful to have been a part of this amazing project. Thanks.
So we've not really covered the topic of well yet. And because the built environment has such a tremendous impact on people and their health and wellness, we'd be remiss if we didn't bring up the added benefits that the certification system can bring to the table. The Well Building Standards mission is to improve health, human health, and well-being through the built environment. One of the main differences from the other certification systems that we discussed in WELL is that the other systems focus on water use. WELL encourages people to drink water by providing access to clean drinking water. And it's also about managing water both related to the building enclosure and on the interior through inspections, enclosure commissioning, and appropriate selection of materials. This all has an influence on the air we breathe inside a building. So in the summers prior to COVID, when I shared cucumbers and other vegetables from my overactive garden with my coworkers, all the veggies were gone in a matter of hours. We also shared candy in the office, that we brought in after Halloween or when we had leftovers from kids' parties. It was also typically gone in a matter of hours. The difference being that after indulging in the candy, we all complained about how unwell and sluggish we felt, and it didn't help us to work any better. WELL addresses this sort of behavior by promoting healthy eating habits, by making healthy food options the easiest choice, and through portion control, transparency, and encouraging healthy eating environments. Because our circadian rhythm is so ingrained in us as humans, WELL encourages the use of circadian lighting using electric lights. Our circadian rhythm impacts our quality of sleep, our mood, and our cognitive functions. I know there's a big difference in my mood when I wake up to the gentle glow of my circadian alarm clock versus being awoken in the dark by an annoying alarm that is blaring awful noises at me. So sitting is the new smoking. WELL encourages us to move through the building at our workstations and its site through design strategies and its location, as well as through policies and programs. So this could be locating the building in a walkable neighborhood, providing sit-stand desks, promoting the use of stairs over elevators, or having a fitness room on site or providing gym memberships. Strategies in WELL help relieve workplace stress and anxiety. This can be incorporated into the design by providing access to nature or through policy strategies that support restoration, productivity, and focus. For example, limits on our hours worked or mindfulness training courses. So moving on from WELL and wrapping up the presentation. Certifications provide accountability and are a necessary tool. They hold everyone on the team accountable to specific standards and requirements. When certifications are not appropriate for a project, they should be used in an adaptive way to achieve the best outcome for a project. So whether certifications are utilized, or even if they are simply referenced for strategies, they encourage a holistic approach which fosters communication, collaboration, and value sharing within and beyond project teams. Thank you for joining us today.